Hey there, Mo Robinson-Smith, reporter with Spaceflight now. We're about a year away from the point in which NASA says it will be able to launch its second mission in the Artemis program. And a lot's been happening here at the Kennedy Space Center in preparation for not only that, but future Artemis missions. In fact, you can see the Pegasus barge is here at the turn basin, ready to offload some materials for the Artemis 2, 3, and 4 missions. And at the same time, over here at the mobile launcher out at Launch Complex 39B, they're going through some of the final checkouts before that mobile launcher is ready to roll back to the vehicle assembly building ahead of stacking the Space Launch System rocket itself. So to learn a little bit more about what's happening out at the pad, we had the opportunity to go out there. So let's take you behind the scenes, tell you what's been happening at the mobile launcher, the work that's still ahead, and the pathway towards Artemis 2. Let's take a trip. The mobile launcher is a 380-foot tall support system designed to transport NASA's Space Launch System rocket.
There it goes.
It was put on full display during the Artemis 1 launch back in November of 2022. In August 2023, the towering structure rolled back to the pad at Launch Complex 39B to continue necessary modifications, checkouts, and testing prior to the upcoming Artemis 2 mission, the first crewed flight of the Artemis program, which is set to launch no earlier than September of 2025.
Welcome to Launch Complex 39B.
Thank you.
This is a very historic location.
That's where we met up with Jesse Berdis. He's the Deputy Project Manager for the ML1. Berdis described some of the work that's been happening since August of 2023.
So what we have been primarily focused on in the last year is essentially doing all of the tests interfaced between the mobile launcher and the pad systems. Those tests include the rainbirds, that's all the water you see on O-deck when we do our launch. We've done tests with the cameras, we've done tests with new systems like the emergency egress system, which you see over here in the blue Mondo right here, and we've been basically making sure that everything, we're essentially bringing the design to real world, real life, and testing it to make sure that our excellent teams that we have out here are 100% confident that they are going to work, and they're going to work right, and they're going to work when we need them to work.
The biggest difference, of course, between Artemis 1 and 2 is that this second flight will include 4 astronauts. Part of the work over the past year included a dry dress rehearsal with the full crew in the loop. Artemis 2 mission specialist and Canadian Space Agency astronaut Jeremy Hansen spoke with us about the experience back in April.
Yeah, it's very special to kind of put yourself in the shoes of your future self, getting up in the morning, thinking you're going to be launching in a few hours, having that breakfast, the briefing, suiting up, driving out to the launch pad, climbing up the tower. Obviously, there was no rocket, so it was a bit of a letdown. But other than that, it really felt like the real thing, and you could sort of imagine what it's going to be like that day. And it's exciting to think about, and even just the view up from the tower. You're like, wow, this is a beautiful place to leave the planet.
One of the biggest pad additions that will help support that mission is the emergency egress system Berdis mentioned. Pad 39B uses a slide wire basket system that extends from the 274th level of the mobile launcher down to a terminus point. This receiving area is at the end of 1,335 feet of cable, which is about the length of 4.5 football fields.
So the beginning of our tests back in January were baby drops of the baskets. We were testing specific things one step at a time until we felt confident and comfortable enough to expand those tests all the way to the mobile launcher tower and doing full drops from the mobile launcher tower to the terminus site. And when I say drop, is it a release of the basket from the interface on the tower, and it will glide down the track cable. It's a conveyanced cable, and it will very carefully slow down and land in the landing area a couple feet off the ground so the astronauts can safely evacuate and make their ways into the personal protective vehicles to get to safety.
Berdis says it takes about 30 to 45 seconds to get from the top of the tower down to the bottom. The timing depends on how many people are in the basket and what direction the wind may be blowing. Typically, they're designed to carry up to 5 people. The emergency egress system uses a magnetic braking system, similar to the technology used in theme park roller coasters like those found in the Orlando area.
And at this point, we've seen a lot of things that have happened that we didn't expect, given that it's a new system. And we've learned from it, and now at this point we are very confident that this system is ready and it is ready to support our team to launch.
NASA also has a requirement that the system needs to be able to be either set up or taken down within 8 hours.
That being said, a lot of this system can already be pre-set up well before the crawler gets here, and vice versa. So the idea is we do everything we can to set up everything before the crawler gets here, and then when the crawler arrives, we do the final hookup between the pad, track cable system, which is a wire rope, it's the conveyance that the baskets ride on, and then hook that up to the interface of the mobile launcher and do that final configuration. So that final bit has to be done in 8 hours in the launch time frame, getting us ready for that launch.
In addition to the emergency egress system, NASA has also been running a series of tests on the crew access arm. Those include doing multiple swing tests both towards and away from where the Orion spacecraft will be located.
We don't plan on this, but if there is an emergency and we have to evacuate the astronauts, that crew access arm has so many seconds to full more than 180 degrees turn around and basically interface very carefully to the Orion capsules to give them that access off the tower and then down our emergency egress system, or EES system. So the data that we've been collecting from all of the swing tests are essentially making sure that that arm, when it activates, the hydraulics of the arm and the electronics and software activate it with the right enough amount of speed and torque to come around and slowly pick up speed and then slowly decelerate, so we don't obviously, impact the Orion capsule. That's the worst case scenario, and we're not planning to do that. And so we're making sure through our testing that that will not happen, and we know exactly where that crew access arm is going to come and slowly soften to interface with the Orion capsule.
With the crew access arm and the emergency egress system in place to support crewed missions, the Exploration Ground Systems program, along with the astronaut office, ran a series of checkouts in August called the Integrated System Verification and Validation Tests.
And so what we did was we brought out representatives for the astronaut crew. We also brought out the closeout crew and the fire rescue crew, and we basically did a run-through. We did a day run-through and a night run-through. We had fire suppression water online, and we were basically trying to understand, now that the system's been built, everyone's known about this system for a long time. We've looked at the designs, but now it's time to practice it like you would in football. And so this was kind of our football practice. We wanted to learn the muscle memory of what it takes to evacuate in the time that we would need to, in case we do in the real world. And we got a lot of feedback from them. There were things they liked, there were things they didn't like. Some of the comments that they had, just like you said, a couple of handrail modifications required. The backboards kind of got held up as they were coming around a corner, or they weren't able to, identify something specific. They have helmets on, and you've got water hitting you in the helmet, so it's sometimes difficult to see. And so it was a lot of comments like that saying, can you make this a little bit more obvious of where I need to go, or what I need to grab onto, or modify this handrail here and there. So we got a lot of good feedback. We are now actively working that. It's development partnered with the launch team to make sure that any of their comments are fully addressed and modified and ready to go for launch.
Before the mobile launcher is ready to roll back, Berdis says they need to finish testing with the crew access arm, doing some architectural finishes based on the astronaut feedback, and then clear any so-called foreign object debris, or FOD, from the tower.
We're going to wash it down. We're going to make sure that thing is pristine and perfectly clean, so that when we get into operations and we turn over from development to ops, they have a perfectly good piece of government equipment ready to go for that clean requirement of the stacking operation. So the final thing we're going to do when we're out here at the pad is fully clean that mobile launcher to make sure that we're clean.
Many of those working on the development side of this process will soon transition to the operational work as subject matter experts during the rocket stacking process. This mobile launcher will be used for just 2 more missions in the Artemis program. Starting with Artemis 4, NASA needs to transition to the Mobile Launcher 2, which will support a taller version of the Space Launch System rocket. However, contractor Bechtel is still very much in the construction phase, years behind schedule and dramatically over budget. An audit from NASA's Office of Inspector General found that as of August 2024, the ML2 project contract value nearly tripled from the $383 million in 2019 to $1.1 billion, with the delivery date delayed 3 years to now 2026. The OIG report also projects that the total cost could balloon to $2.7 billion and won't be ready for delivery until August of 2027. That estimate means the ML2 wouldn't be ready to support a launch until spring of 2029, well after the September 2028 goal for launching Artemis 4. Construction of the ML2 remains ongoing near the VAB, as well as elsewhere at the Kennedy Space Center. For now, the Exploration Ground Systems team is pressing ahead with work towards the Artemis II launch, which is set to lift off no earlier than September 2025.
We have the people that have the experience from Artemis 1 and the space shuttle before us, and I'll say it again, these are the right people, they know what they're doing, they've done this before, and they're basically unmatched to anyone else that knows how to work on these systems.
NASA estimates that the mobile launcher will be ready to return to the VAB ahead of stacking sometime in early October. Reporting for Spaceflight Now, I'm Will Robinson Smith.